Quantum ghost particles. Take a look at your hand. Go on, hold it up. It seems solid, stable, and undeniably. It's made of atoms, which are made of protons, neutrons, and electrons. These are the fundamental building blocks of you, the chair you're sitting in, the air you're breathing, and the distant stars. For nearly all of human history, we've operated under the assumption that this matter, this, is permanent. It exists. It's there. But this comfortable illusion of solidity is perhaps the greatest deception the universe has ever concocted. Because beneath that veneer of stability lies a truth so profound, so utterly bizarre, it borders on terrifying. This is the universe's most unsettling law. At the most fundamental level of reality, nothing is truly solid, and every single particle is a ghost on borrowed time. What you perceive as a continuous, stable existence is actually a furious, non-stop dance of creation and annihilation. The very fabric of space-time, the vacuum we once thought of as empty, is in fact a seething, riling cauldron of potential. This is the realm of quantum fluctuations. Imagine the calmest ocean you can. From a distance, its surface looks perfectly flat and still. But get closer and you'll see it's a chaotic mess of tiny waves, ripples, and bubbles, constantly forming and collapsing. The vacuum of space is like that, but instead of water, it's a field of pure energy. And out of this energy, particles are constantly being born. These aren't the normal particles that make up your hand. These are something else entirely. Physicists call them virtual particles. They are the ghosts in the machine of reality. In an incredible act of cosmic embezzlement, a pair of particles, one matter, one antimatter, can spontaneously emerge from the absolute nothingness of the vacuum. They burst into existence, live for a fleeting, almost unimaginably short moment, and then crash back into each other, annihilating themselves and returning the energy they borrowed back to the void. This isn't a rare event. It is happening everywhere, all the time. It's happening in the space between your eyes and this screen right now. Trillions upon trillions of these phantom particles are winking in and out of existence in every cubic centimeter of space every single second. The universe, at its core, is a flickering, strobing, chaotic foam of these temporary ghosts. How is this even possible? How can something be created from nothing? The answer lies in one of the pillars of quantum mechanics, the Heisenberg Uncertainty Principle. We usually think of it in terms of position and momentum, that you can't know both a particle's exact location and its exact speed at the same time. But the principle has another, even more profound version that relates energy and time. It states that you cannot know the exact energy of a system for a specific, infinitesimally short slice of time. There's a fundamental fuzziness and uncertainty. This uncertainty provides a loophole in the law of conservation of energy. That law says energy cannot be created or destroyed. But the uncertainty principle says that for incredibly short periods, the universe can get away with it. Nature allows energy to be borrowed from the vacuum, as long as it's paid back very, very quickly. The shorter the loan period, the more energy can be borrowed. So, a pair of virtual particles can pop into existence, borrowing their mass energy from the void, but only if they annihilate and pay back that energy debt before the universe notices. They are on borrowed time, quite literally. The more massive the virtual particle, the more energy it has to borrow, and therefore the shorter its existence is allowed to be. They are the ultimate high-risk short-term loan from the cosmos. You might be thinking this all sounds like theoretical nonsense, a mathematical trick. But the effects of these ghost particles are very, very real. They are not just theoretical constructs. We can measure their influence on the world we see. The Casimir effect, for instance, is a physical force that arises directly from quantum fluctuations. If you place two uncharged metal plates incredibly close together in a vacuum, they will be pushed toward each other. Why? Because the tiny space between the plates restricts the kinds of virtual particles that can pop into existence there, while the infinite space outside the plates has no such restrictions. The pressure from the ghost particles on the outside is greater than the pressure from the inside, and this imbalance creates a real measurable force. These ephemeral ghosts are capable of physically moving objects in our world. Their collective presence subtly alters the energy levels of electrons in atoms, a phenomenon called the Lamb shift, which we can detect with incredible precision. So, while each individual particle is a fleeting phantom, their combined, constant presence fundamentally shapes the reality we inhabit. They are the invisible scaffolding upon which our seemingly solid universe is built.
Ephemeral reality implications. The revelation that our universe is built upon a foundation of fleeting, temporary ghost particles is more than just a fascinating piece of physics. It's a philosophical earthquake. It forces us to confront the profound implications of living in a reality that is, at its most fundamental level, an illusion of permanence. If the bricks are temporary, what does that say about the house? If the very atoms that constitute your body are themselves underpinned by a chaotic fizz of particles borrowing time from the void, what does that make you? It means that the solidity and stability we experience every moment of our lives is an emergent property, a grand statistical average. It's like watching a movie. We perceive a smooth, continuous flow of motion, but we know it's actually just a rapid succession of thousands of static individual frames. Our reality is similar. Each moment is a snapshot of an impossibly complex configuration of these quantum ghosts, a temporary arrangement that gives rise to the illusion of a solid, persistent world. The universe isn't a static stage, it's an ongoing performance of unimaginable fury and speed. This inherent instability is not a flaw in the system, it is the system. It's what makes everything possible. A truly static, permanent universe would be a dead universe. It is the constant flux, the creation and annihilation, the borrowing and repaying that drives the engine of cosmic evolution. This connects directly to what we perceive as the arrow of time. The universe is constantly changing, moving from states of lower entropy to higher entropy, from order to disorder. This forward march of time is powered by the ceaseless activity at the quantum level. The universe is not simply, it is. And this process of becoming is woven from the threads of impermanence. Every interaction, every chemical reaction, every star that shines is mediated by the exchange of forces, which themselves are carried by virtual particles. The fundamental forces of nature are, in essence, conversations carried on by these ghosts. Without this constant ephemeral dance, atoms couldn't hold together, light couldn't travel, and the universe as we know it would be impossible. The implications of this ephemeral reality stretch to the grandest cosmic scales and the ultimate fate of everything. Nothing, it seems, is exempt from this law of borrowed time. Consider black holes, the universe's paragons of permanence and inescapable gravity. Even they are not forever. Stephen Hawking famously predicted that black holes must evaporate over immense timescales. And how do they do this? Through virtual particles. Right at the edge of a black hole's event horizon, pairs of virtual particles can pop into existence. Occasionally, one particle will fall into the black hole while its partner escapes into space. From an outside perspective, it looks as though the black hole has just emitted a particle. Because the escaped particle can't annihilate with its partner, it becomes a real particle, and its energy has to come from somewhere. It comes from the black hole's mass. Slowly, drip by drip, over trillions of years, the black hole radiates its own mass away until it vanishes in a final flash of light. The most permanent objects we can conceive of are ultimately unraveled by the universe's most transient entities. This brings us to the ultimate and perhaps most terrifying question. What does this mean for us? For our existence? It presents a profound paradox. On one hand, it can feel deeply unsettling, even nihilistic. If everything is just a temporary flicker, a cosmic accident of borrowed energy, does anything truly matter? Are we just complex, fleeting patterns in the quantum foam, destined to dissolve back into the void from which we came? It highlights our own insignificance in the face of cosmic timescales and the fundamental impermanence of all things. The feeling of being solid and real is a trick of scale, a convenient lie our senses tell us to help us navigate the world. But there is another way to see it. Perhaps this law doesn't make life terrifyingly transient, but breathtakingly precious. If our existence is built upon such an improbable, fleeting foundation, then every single moment we are here, every moment we are a stable, conscious configuration of these ghost particles, is a miracle. It's a temporary masterpiece painted with the universe's most ephemeral ink. We are not separate from this cosmic dance. We, the dance. We are the universe experiencing itself through a temporary collection of borrowed energy and time. This perspective doesn't diminish our existence, it elevates it. It means that the present moment is the only thing that is truly real, a beautiful, fleeting illusion woven from the universe's most fundamental and mysterious law. The universe is not a collection of things, it is a cascade of events. And for a brief, brilliant sliver of time, we get to be one of them.